Hi everyone. We're going to look at how to do the quadratic formula, how to use the quadratic formula to solve a quadratic equation. You can always use this method. You can always use this formula no matter if it's factorable or not factorable. It will always work to give you the answer, which is kind of nice if you want one method that will always work. So the equation is, for the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. There's a lot of videos on YouTube that make cool songs out of this formula. So if you need help remembering it, well, first off, it's on your reference sheet, so you don't have to do that. But it's kind of cool just to memorize the formula, and it's not too bad. So that is the formula we're going to use for this, solve these equations. So we have to know our a, b, and c. That's not too hard. And then we just plug it in. X equals negative b, so negative 9, plus or minus the square root of negative 9 squared minus 4 times our a times our c, all divided by 2a. And that looks terrible, but it's really not that bad. This would be 9 plus or minus the square root. What do we got here? Well, this is 81 for negative 9 squared. Make sure you use parentheses when you type this in if you're not sure what that is. Then negative 4 times 7 times negative 8. So we got to multiply this out here. So it doesn't matter the order of multiplication ever. It's your commutative property. So negative 4 times 7 would be negative 28. And then that times negative 8, well, that would be a positive. 8 times 8 would be 64. 8 times 2 would be 16. Plus 6 would be 22. So plus 224 all over 2 times 7, which is 14. Wow, this looks kind of crazy, but it's not that bad. Don't worry. So this is going to be 9 plus or minus 81 plus 224 would be 300. 305 all divided by 14. So that is an answer. That could be your final answer. But that is the answer to this equation. That's all you really have to do. Unless there was a way to simplify the square root of 305, that would be kind of nice. So we take square root of 305, and we look for factors of 305 that are perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. 9 squared is 81, 10 squared is 100, and we probably want anything above that, I'm guessing. 11 squared would be 121, and we'll just kind of make sure that none of those are factors of 305. So we just take 305 and divide it by them. I know 100 is not going to work. That one's pretty clear. 305 divided by 121, it seems like that's not going to work either, and it doesn't. 305 divided by 81 does not work. 305 over 64 does not work. 305 over 49. Yeah, it seems like nothing is working so far. This might just be our final answer, which is totally fine. Yep, nothing seems to be working here. 305 divided by 9. Yep, nothing's going to work here. It's not going to be divided by 4 because it's not even. So that's actually it. That's going to be our answer. 9 plus or minus square root of 305 over 14. You could break this up and call it 9 over 14 plus or minus the square root of 305 over 14. But is that really simpler? Not really. It's just a different way to write it. All right, let's try the next one. So this one, we've got a GCF. It's always good to have a GCF because it makes your numbers smaller and easier to work with. So in this case here, we can take out a 2 out of everything. So 2 times 2x squared minus 1x minus 1. So we've got much smaller numbers, which will be nicer to work with. And then we can just use this trinomial in our quadratic formula because the 2 doesn't do anything. 2 is not a possible solution. So I can essentially divide by it on both sides because you can't have 2 equal to 0. So we're really looking to see, okay, when does 2x squared minus 1x minus 1, when does that equal 0? Because we know 2 is never going to be 0. So now using our quadratic formula, this is, we use the new one. Let's use the new values here. So a, b, and c. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This would be 1 plus or minus the square root of 1 Negative 4 times 2 is negative 8 times negative 1 would be 8, positive 8, all over 2 times 2, which is 4. And then from here, it looks like this is going to be kind of nice. We got 1 plus or minus the square root of 9 all over 4. Now, the square root of 9 is actually a integer value, so this is 1 plus or minus 3 over 4, which would be 1/4 plus or minus 3/4. So 1/4 plus 3/4 would be one option, which would be 4/4, which is 1. Or 1/4 minus 3/4 would be negative 2/4, which is negative 1/2. There's our two answers, negative 1/2 and 1. And either order is totally fine. And that's it. That's how we use a quadratic formula. Even though it actually was factorable here, we can use it to find our answers a little different way. You could have taken this 4x squared minus 2x minus 2 and factored out the GCF first. And then we could have done our factoring of this, because if we got rational roots here, that means it's going to factor. So we could have done 2x times something with x in it, and then it's going to be 1 and 1 in order to multiply to 1. In order to make this work, you have to have a minus here in order to make that a negative 2x and a positive 1x in order to make this work. And then you would get x equals negative 1/2 and x equals 1 when you go to solve those. So same answer by factoring, but of course you can always use a quadratic formula, and this just proves that you can use it even when it's factorable.